Did I? Yes, I did. Ta-da. Ta-da. Wow, Jen. Cool. Then my name is Michele Tedesco. I am actually an Italian/Swiss, Swiss-German actually. Yeah. Microphone. Ah. So because of the recording, it's anyway recorded over that.
No. Yeah, exactly.
And the audio quality is good.
And if you want to be
because of you all.
Yeah,
okay.
There's a portable microphone here,
cool.
which is in
over there.
Here. Yeah, exactly. Let me. This goes on the ear thingy. And this.
So your thing is done.
And then 1, 2, 3. Just click this.
1, 2, 3, and fantastic. Usually I'm not such a big room speaker, but a small room speaker. So let's get this also here. So again, good morning. My name is Michele. I am a so-called technical solutions professional at Microsoft. My aim, or where I'm concentrating my daily work, is all about DevOps related tasks or stuff all around application development based on the Azure cloud. So this is what I usually do. I used to be a Scrum Master and like a software developer in the past, all in the .NET sort of space. And while being a software developer at a bigger pharmaceutical company, I was closely working with, at the time, the TFS guys, so the DevOps guys for on-premise stuff. And I reported so many bugs at that time as a Scrum Master that they actually, after a while, asked me, hey, do you want to join our team? That will make the communication easier. So this is how I then find my way into Microsoft. The aim for today, as I've already mentioned, is to give you an introduction about this topic of DevOps, how Microsoft understands it, what are the tools that potentially would actually help you become more agile, apply some DevOps practices, some daily stuff. It would be fantastic to have not a just one-way presentation, so whatever question you have, whatever things you are not actually agreeing with me, have concerns or another critical view, just bring it up. The more dynamic it is, the more I think it's going to be a learn-rich experience. I got that new cool pen, and I was told that just by clicking, wow, the slide will move, which is cool somehow. So for the ones who have never, discussed or actually experienced DevOps, that's like a funny pictures. For others who have already have some conversation about DevOps, that's like a known picture. But the point here is that when you talk to people, when you ask 10 different people, hey, what is your understanding about DevOps? You get 11 different descriptions of their understanding, their rephrasing about what DevOps is. And we have in Microsoft, we have a cloud developer advocate team. So it's that team which actually is focusing especially on the developer crowd. And one of those guys have actually a very, for me, insightful representation of what DevOps is. Let me show you that.
That's a little faster than I thought it would be.
So, with that said, what difference did you notice between 1960 whatever and 2000 and something?
Hammer.
The hammer.
Hammer.
The hammer? Yeah, that's something which
More people.
more people,
People no refueling.
no refueling, fantastic.
Blue car,
Blue car, black car.
No, but also, and also the mechanics of the car was completely different. Like the amount of time just to take it off the wheel was phenomenal.
Okay. Teamwork. So fantastic. I want actually to focus on 2/3 things. So more people is an important aspect, or is something which is actually completely different. And usually, what I have experienced from the past is it's also a very straightforward approach of a company saying if it's not speed enough, if it's not fast enough with 5 people, let's put 50 on it. And even though that represents that very straightforward thinking of like, if it doesn't work with 3, let's make it 50, or let's make it like 15 in this case, that's not what the video is showing. But the video is showing is that to improve or actually to get rid of a specific bottleneck, sometimes it makes absolutely sense. As of today, with all the engineers that we have, engineers for infrastructure, engineers for operating infrastructure, engineers for security, engineers for the process, the developer, the different shapes of developer, engineers for everything, so that they somehow will be needed or are needed as of today, not just because more men can deliver more work, but because potentially by having just more men, but not too much, can actually very fast improve the speed. So it's a fair point to say even DevOps doesn't just mean that the same 2 people doing DevOps are automatically becoming faster. Potentially there needs to be more effort, but the outcome of more people could be exponential and not just a linear thing. The second thing is a combination of 2 aspects. And in the DevOps boss world, people call it shift left. And one idea of shift left is actually, and you've mentioned one point, is that whenever you recognize that there is a bottleneck, and one of the difference here is that with the year, the team has learned to shift left, for example, for refueling. So the refueling strategy in the future, or in this more futuristic way of actually having a pit stop, the refueling strategy was shifted left. It was part already of the planning, so that by the last pit stop, there was no need to refuel just because it was the process. No, the people knew, okay, we will start with a full tank because that's going to help us having a faster pit stop at the end. Whereas in the past, that was all, okay, we have a man for refueling, so every time there will be a pit stop, there will be somebody refueling it. It was not actually included more on the left side, it was every time the same, different step. And we're going to have a look at that. And the DevOps part here, or the DevOps mindset here, is actually to learn about what are the bottlenecks and step by step tackle them. And with the aim to improve it like exponentially as long as you can. With that said, so what we at Microsoft would like to provide you is, or one way to see DevOps, or to rephrase it again, is DevOps is consisting of different aspects. DevOps is consisting of culture and people. So it's a people thing which you cannot solve with tools. It's a mindset thing. Then DevOps has a part of process. So to be able actually to streamline such an efficient way of having a pit stop. It's a part of a process. People need to know what to do. People need to think. People need to optimize, and so that's a process thing. But also somebody mentioned the hammer. So even the tools to do such a pit stop have changed. A lot of things in the tool set have changed. So it's not just a hammer that makes that faster, but it's a combination of having now not a hammer, but something faster to switch the switch the tires, to have a process of having even a backup person. I don't know if it's visible there, but every tire changer has a backup person just in case it falls down or something like that, to improve the process, and even the cultural aspect. And one cultural aspect here is we have, it's not clear in that picture, but we have two people here not contributing directly to the pit stop itself, but actually taking measures, taking care of KPI, so that they can feed the KPIs back and learn constantly, and constantly continue to improve it in, I don't know, what's the physical like limit of being as fast as possible, but actually to still have the target to be as near as possible to the physical limit of having a pit stop. So the learning experience is what still they are not just fast like hell, they want even to become even faster and faster. So that's the cultural aspect that has been also there, which is somehow also part of the DevOps mindset. So with that said, what I would like to focus more in the morning is more of the tools and the process that we at Microsoft are using or actually making available to our customers to reuse. And then in the afternoon, it's going to be more a discussion of process and culture. So what are the learnings of our own team, which is a funny fact. What I'm going to show in the afternoon is how the Azure DevOps program team is building Azure DevOps with the tool which is Azure DevOps. So it's like the matrix. It's right. You build Azure DevOps with Azure DevOps, and if it's broken, you will see it the next day because you're anyway using the same tools that you're building. And the cycle that I want to go through is actually, as it says, it's actually a cycle. So it's not something which I've learned from the past, that a lot of companies still are actually looking at a project or product, not life cycle, but it's like a time frame. You start somewhere, you get the requirements, you implement a product, you test a product, you deliver a product. That's a project life cycle. Stop, and that's it. What Azure DevOps tries to target, or where it fits best, is when you have a life cycle, where you have a learning actual experience, and actually you are reiterating or building a product and delivering value. At the beginning, actually, still a big part of Azure DevOps is all about software. Whenever people are building software, that life cycle fits very well. But we are learning at Microsoft that there are so many spots where that can also help without actually being software, the output of the delivery itself. Just a few numbers to have mentioned it, because I still find it fascinating, and they're anyway already outdated. But what we have today is around 80% of all the Microsoft employees are working day by day by using Azure DevOps. It's now 90,000 over there. It's now roughly 100,000 people at Microsoft. And these are just internal stats. I have done at the end of the slide, like even the official, like all over stats. But what is like interesting is that things like 500,000 million test executions, which happen only by executing the test of Azure DevOps. So many cycles, which are actually, so many tests that are actually executed every day. And the funny fact at the beginning, when Azure DevOps launched, is that we used to have just an on-premise product, which was called, which was called Team Foundation Server. That was the on-premise version that you got the CD and could install to have the same tool suite experience. And one difference in actually gathering the feedback, and why this is actually really impactful, is that in the past, when we delivered that new cool TFS 2012 or 2013 to our customer, and we got and asked feedback like, hey, do you like it? And the customer was like, I really like it, even though that screen is not actually that user-friendly. If you would turn this and that would actually be far better. And by the way, there is a bug. And usually the answer was, thank you for the feedback. In 3 years, we're going to have a new product. So we will make sure that your feedback will be included in the product. We're going to improve the UI and fix the bug. So that was like the life cycle. Today, the life cycle is about, hey, let me fire a bug because there's something not working. Directly in the backend, through a lot of automation and standardization, a bug lands on the desk of some support over here, which is actually tackling it like right now. And if it's a huge bug, it's going to be tackled now. And like 60 or 90 minutes later, potentially the bug is solved, and everybody worldwide will then have already a fixed solution. So that's like the difference which we have achieved. What I'm going shortly to demo is a part of DevOps which is tackling more of the continuous integration part, which, to be honest, what I've tried, and I can show that later, I've tried to go to the GitHub repo of the DNN platform, tried to actually just build a continuous integration pipeline, as we're going to see soon, and I failed. But potentially we can have a look together and see and experience how actually such a pipeline works, and you can help me fix the issues. Then the second part is the continuous deployment. Also something that we have learned from the past is actually that you can build software as fast as you want, but as long as you don't get it shipped to your customers, as long as then the customers are not actually able to give you feedback, then there's no value actually in investing so much time in improving so far. So we have, by applying this continuous deployment sort of approach, what we have also changed is something which in Scrum, for example, it's called the definition of done. Over time, our definition of done has become, if it's running in production and our KPIs are telling us that users are using it, that's done. Before, that's not yet done. This is like still in production. This is still not finished, right? Even though the software is written and it's on the production server, that's not what we define as definition of done. So these are some details that we're going to look at in the afternoon. And yeah, this time actually to the last point, the monitoring aspect, which usually then goes back to this classic DevOps cultural thing where you say, hey, I'm a developer, I've developed it, that thing does work, and usually people say it works on my machine, so it needs to, I expect that it works everywhere. So when you then give it then over to an engineer, which in the operation then needs to actually install and maintain something like that, that's like the wall which DevOps tries to achieve. And by having something which is continuously learning, that's the feedback loop where actually you try even to include the customer telling, hey, that's working or not, and then you have like a closed loop. What we are going to have a look today is how Azure DevOps, which is consisting of those five major features, what Azure DevOps is from a tools perspective, and then how Azure DevOps can be applied, which is more the process aspect. Now, just to be aware of how many of you have already, so how many of you know about Azure DevOps in general? 1, 2, 3, 4, 5, 6, 7. I expected more. From the ones who have seen or who know what Azure DevOps is, how many of you are using it, let's say, regularly? Once a year, once a week, once a day? Okay, fantastic. The others who don't know about Azure DevOps, how many of you are doing some sort of continuous integration, continuous deployment? 1, 2. Okay, cool. So we still have people in the room which are developing software and then sending an email with a zip file, I assume, something like that. Raise your hand. Okay, cool. So the goal of today is actually to show you like an end-to-end sort of thing, so an end-to-end life cycle where you're coming up with a piece of software, but with the expectation that this tool suite is helping you to have that piece of software in production as soon as possible, but with the highest quality standard as possible during the pipeline of actually bringing it step by step forward. Yes. one word about open source. I picked up that this is like a Microsoft crowd, which is fairly nice for me to have this sort of conversation. But usually when we talk about DevOps, we have a lot of customers out there which are doing already DevOps, but that never touched upon Azure DevOps itself, because the tool suite that they're using is another one. And usually it's a tool suite which is supported and enriched by the open source community. So what is our intent with Azure DevOps is also to not just, like in the past, saying either it's SQL or it's nothing. We don't support you anymore if you're not using SQL when it comes to relation databases. The Azure DevOps approach is like to say, we understand that from a life cycle perspective, we need to have something which helps you plan and track your stuff. We need to help you to have something where you can actually store your versions of the code or whatever things you are building. We understand that you need to plan how you are planning to bring that piece of code to production, so to have a continuous integration and continuous deployment pipeline. We are sure that you need to have a sort of a process where you can constantly learn whether it was a very interesting discussion about GDPR and a new feature that has been added to the platform. And one interesting aspect I would now expect to know about is that, do people actually use that? So somebody has invested time. The feature works, and the feature is actually cool, but do people use it, or do they take other approaches? And if they use it, what is the feedback? Do they like it, or do they use it because they are forced? So all these sort of insights are very important. So we understand that we need to have some sort of a monitoring and KPI over there. Yeah. So the message here is that no matter whether you are actually starting the journey saying, hey, I just need all that, I don't have anything. So Azure DevOps provides you with the whole lifecycle experience. Or you're saying, you know what? I have already practically the whole stack in place. Or, yeah, the whole stack in place, but not related to Azure DevOps, which means for the planning, in this case, Trello and Jenkins for CI and Terraform and Ansible for the continuous deployment part and so on. What Azure DevOps is actually aiming to is to say, okay, fair. If you have already a lot of skills in your teams, in your company, where you're using those skills to build a already mature CI platform, and also the deployment, the infrastructure as code sort of approach to deploy your infrastructure is already absolutely fine and mature because you're using Terraform. Then potentially, if you are missing out other parts, this is where you can then tie in actually Azure DevOps. So you have already a part of a pipeline, but the moment you're actually missing part of it, this is where Azure DevOps could be an enhancement. Any questions so far? So you believe me, you trust me, everybody's happy. No concerns. So yeah, that's more the message when we meet the open source community. It's to make sure that the message is that it's not going to replace or actually to exclude anything. It's like, hey, do the best you can, but if you find a bottleneck, like the tanking task, if you find a bottleneck and you want to tackle it, and you don't have the right tools yet, Azure DevOps can tie in whatever other pipeline that you have already built up. Yeah, so in a summary, as shown here on the top, so a lot of people are coming already with a GitHub account because they are working in a distributed team. So for them, there is no value actually to move all those repositories to DevOps, to the DevOps repository sort of feature, because GitHub is doing already fantastic. There is no need, there is no added value. And this is why you stick with GitHub. I picked up there was a lady, at least a bit at the beginning, who is doing mostly infrastructure work. If she's actually delivering or deploying all the related infrastructure by using Ansible, for example, that's absolutely fine. This is how you can progress and continue. But assuming that the planning is not actually being done so well because it's an email conversation or because it's in an Excel sheet or something like that, this is where you can tie in pieces of DevOps. Or there, a lot of customers are challenging us saying, hey, our company has a big history in using Jenkins. So we are not moving away. But usually what we figure out is that Jenkins is a fantastic tool for continuous integration. But when it comes then to continuous deployment, to have a process, a controlled process on how I actually install that piece of software into production, they are hacking their own thing. And that can work, but if you want to, if you see that as a risk or as a bottleneck, potentially you can reuse or Azure pipelines, release pipelines to tackle the release aspect of your continuous integration and deployment pipeline. And one important aspect in addition is that we are also contributing to all those open source projects too. So it's not just the Azure DevOps feature set that is evolving, is actually then evolving all the other tools that integrate with Azure DevOps. Just because, as mentioned at the beginning, only when you have a full life cycle covered, only then are you actually capable or able to improve at speed of light, more or less. But if you're missing some points, it's like when you're missing the hammer. So everybody's ready, but there is no hammer. Then still the whole process isn't actually improving. Any questions so far? No, good. Then Azure DevOps, how to get started. Let's come more to the practical side. No, that's the pipeline missing. No, you don't see it. Just a second. To switch to here. Not. Yeah, but I think it's clear. So if you want to know more about Azure DevOps and to get started, we have, so if you browse the URL azure.com/Azure DevOps, this is where you can at least get started with. An interesting aspect of Azure DevOps, especially for smaller teams, is that the service itself is completely free for the first 5 users. So if you are a team or startup out of 5 users, it's completely free of charge. If you are a bigger company consisting of 100 users, of 10,000 users, then yes, there is an enterprise cost with it, but with smaller teams, it's absolutely free of charge. So you can then start a free account and start working with it. Also something which I want to highlight, and this is not just specific for Azure DevOps, but it's here in the context of Azure DevOps, is the documentation. So the Microsoft documentation, which can be found under docs.microsoft.com, now here, as an example with Azure DevOps, is the right starting spot for everything in the Azure cloud, but also for Azure DevOps. And just as an example, for someone which has never actually worked with Azure DevOps, for example, there are a lot of already quick starts where you can just, even though you have never touched upon it and you don't have a Microsoft specialist or colleague who is helping you, these are like micro hands-on lab where you actually walk through different aspects of Azure DevOps. And the same is for each and every other Azure service. You will get the experience of like a walkthrough thing that actually at the end will help you achieve something. Here's like if you want to sign up, or if you want to build your first Git repository, and so on and so on. So the Azure documentation, if you want to get started, is the best place where you can know more about that. Whenever you have signed up for an account, the easiest way to start it, also where you get then forwarded to whenever you have signed up, is to the URL, which is called dev.azure.com. And this is where, as you can see here on the left side, you will get access to one or even different so-called organizations. Azure DevOps is a software as a service, and it consists of an outer structure which is called an organization, or in other words, it's an account. And as a company, you can have one account or even multiple accounts. The only thing that actually differentiates them is the URL. So each and every account gets a URL. So potentially, I can now check where there is a dev.azure.com/DNN, and then we can figure out whether, I assume, somebody owns that. The moment you have actually created such an account, or in Azure DevOps, an organization, you can start creating different projects in this organization. And as you can see here, I have an Azure demo, and another Azure demo, and another Azure demo. And you can start building these sort of team projects, which are actually holding a product or a project that you are building. And that can be, for us at Microsoft, that can be Azure DevOps itself, or for example, Azure SQL or Azure VMs. All those are different projects that we have all under the big account of the Microsoft engineering. I can show them the details then in the afternoon. And so whenever you build a new account, let's go into one of those. Here we go. We have something which is like, you will enter, so the first screen that you will see is like a dashboard. And the dashboard is meant more for people like stakeholders or people which want just to get be informed, to get informed about the status of what is happening within that team project, but don't want yet to drill down into details. So assuming that you want to know, okay, how many bugs, like here, do we have actually currently? So you as a developer are actually tackling a new feature into Azure DevOps. But you know from colleagues using the DNN platform that there have been reported a few bugs in the past, which a friend of you is actually working on. So instead of actually going into the whole list of what is happening, into the bug, who is owning this overview is actually aimed for everybody to have a look, a one glass view saying, okay, I know somehow where we are and what we are tackling. We will have a look then in the afternoon about our internal dashboards, which gets somehow a little bit more complicated than that, but where also there are a lot of gems about how we are actually learning day by day, what are the KPIs which are then reflected in such a dashboard. So the first part, even though, so yeah, in a lot of projects or product, the first thing that you do after you have evaluated whether you're going to build such a business or not is actually you start by typing down a few requirements. And the idea of having those few requirements at the beginning is to know what you're building, but then also later, while you're actually building constantly the product and evolving it, to be able also to prioritize it. And in Azure DevOps, we have here different views on actually what we are going to build. We have actually two abstractions when it comes to project management in Azure DevOps. So one abstraction is more of a Kanban approach. Before I continue, does everybody know what Kanban is? Or who doesn't know what Kanban is? Ah, fantastic. That's more of a spontaneous exploration. There is that cool thing called One Day in Kanban World. Who didn't know about that? Cool. When you have 2-3 minutes, search for One Day in Kanban Land, the Kanban world, and this is the best, like the essence of a software development aspect of Kanban. It just explains so well without actually any words, but just a few pictures. And we at Microsoft are constantly also learning on how to improve even the essence of how we can have Kanban supporting us in driving the product development. So the upper part of Azure DevOps is actually making sure that we have one way to define and give priorities to what we are going to build. In this case here, it's a shuttle application as a demo, which is actually having on the left side all the stories or the requirements that we want to build, and is giving us the ability actually to then find a process. In this case, it's a very easy process. The moment you approve a task that's going to be planned, then you're committed to it, so you know that you're working on that, and when it's done, whatever done means for you, then you are going to say, hey, I've worked on that thing and it's done, it's in production, or it's going to be used. Two major aspects of Kanban, which are actually reflected into here, is visualizing things. And this is why the board is so critical. I used to be a Scrum Master in the past in a bigger pharmaceutical company. And one of my daily life tasks was that people came in knowing, hey, that guy in your team, he knows how to fix our problem. Either it was a SQL specialist who knew how to improve some indexes, or it was a software development, a WCF software guys knowing how to fix that connection between two services that did not work, but they were constantly hijacking people or saying, hey, could you prioritize my story? Could you add this to the sprint? So it was constantly a challenge arguing with them, hey, no, we are working, we want to work in freedom for the term of the sprint. And then we can tackle that again and see how we can change the priorities. That was a time when all those people coming from outside had no idea about what we were doing, just because they were like, oh, I see those guys in the coffee break, so let me add them, let me give them more work, assuming that they can do it, or just add 1 more hour a week, and then that's fine. What we have then introduced is we took some big whiteboards, and my job was actually to, at the time we didn't have the big screens, to just use the digital board, so I actually took the representation, the physical representation of that board, and posted it on a big whiteboard. And every time somebody from externally came in saying, hey, can you please add that? I was like, look, that's our priority plan. If you're going to add this, we're going to kill that. There is no magic. That's like the performance that we can achieve, and there's no more and there's no less. And people starting seeing that, and just by visualizing it, that's helped me actually to put down the discussions practically to zero. So, long story short, visualizing thing is something which is a sense of Kanban, and this is why those boards are actually really, really important. And other aspects are like here on the top, you see those green numbers, which could fast become red numbers when you're actually plan to do a lot of work, because you know that you can do that, but then you have already experienced in the past that you can do only so much. So the moment you're actually adding work over work or work and planning to achieve that in a specific point in time, what we're also visualizing is that we know from the experience that you cannot work on more than 5 things at the same time, or your team cannot do more than 5 things at the same time. Otherwise, the 6th thing, or even more, are going to just be there. So it's not realistic to say that we work on more than so many. So again, there, the visualization part is actually to make aware, say, you're planning work wrong. You're going to have a bottleneck soon, because now you set the expectation that all of that is going to be achieved soon. So this is where the Kanban board is helping a lot. And the moment you have now a good planning, a good overview of what you're going to plan and deliver over a specific period of time, we have then more of a more agile or Scrum-based sort of task board. Let me see when there's an example here, but we will have one here. Yeah, fantastic. So the moment you have defined the sprint, the moment you have defined the work that you have, then we switch more to a more practical approach. In Azure DevOps, what we are actually supporting out of the box is more a Scrum approach or a more generic Agile approach. That doesn't mean that a classic waterfall approach is not supported. I mean, you can still manage to have a more waterfall view on that, but out of the box those are the approaches which is out of the box actually represented in those task board and in those sprint planning sessions. Who of you is still planning in a very, let's say, waterfall approach way? Big requirements catalog, implementing it, and after a while you deliver, and then the project is done. Cool, and it still works? And who of you is already using whatever tool, but these sort of Scrum or Agile-like approaches to actually to deliver work in a more iterative way? Yeah, that's cool. And so since I'm assuming part of you are not using the Azure DevOps stack, are you using something else? Azure DevOps, okay.
Atlassian and JetBrains.
Atlassian?
And JetBrains.
Okay.
Yeah.
Okay, cool.
GitLab.
And GitLab, I heard some more. Okay. Cool. Okay, interesting. So for the ones who are not using it, it's important that you have something to track your work. And I'm coming then at the end to show why it is actually important to have the work first into the system, to then at the end having a full end-to-end tracking of what is actually going into to land into the production system. Then, having covered the board, the next feature set, if you want, so from a DevOps perspective, is what we would like to deliver, or what we want to make sure that our customers have a tool set to achieve that, is all about continuous integration and continuous delivery. So, in other words, is actually giving you the tools to be able to have the source code written on one spot, but then having a system taking care of either compiling or actually just creating the right format for the output, and then in a second step to control and manage how this output, could be something compiled or not, is going to land into production. One thing which is for me, it's still fascinating, is as long as I know, or as far as I know, there are no other like tool suites which are capable to say, hey, we can develop and support you with CI/CD with any language and any platforms. Now, that's a little bit exaggerated. Any platforms means all Unix-based systems, being it Linux or Mac OS, and all Windows systems, or Windows itself, is supported out of the box. That means that if today you're not developing for a sort of web-oriented view where the end user is just using a browser, but you're actually developing a piece of software which needs to run on different operating systems, you would be able now to achieve that by using just one CI pipeline, saying deploy it or build it for this, this, and that out of the box without needing to build your infrastructure, anything like that. If you don't have that need, that's nice to have, but not interesting. There are still a lot of people which have the need of deploying on different sort of platforms, and this comes very handy for them. Instead of having 3 different pipelines defined with 3 different technologies, they get it all out of one box. And the second thing is any language. So we support a lot of the, let's say, the major used language out of the box. And like 2 weeks ago, somebody was actually telling me that they got a CI/CD pipeline working for a VB6 project. So I assume, however they were able to achieve that, that you can really go back and build a system where you can really compile even different, not anymore so common sort of software. Are all of you developing purely on the ASP.NET stack, or are there also other things that you're producing? No? Was it that a yes or no?
Yeah, well, still a VB6.
Okay. What a coincidence, okay. I have a blog post for you then later. Okay?
Yeah, well, it's already automated.
Ah, fantastic. Cool.
Cordova.
I didn't get it.
Yeah, Cordova.
Ah, on Cordova. Okay, cool. It's also out of the box supported.
Expo, React Native.
Okay, which is the Node.js like the JavaScript world. Okay. So I was looking for more like somebody mentioned COBOL this morning.
Yeah,
you know,
that's
so
right.
that's going to be the bigger challenge. But anyway, that's the goal of these Azure pipelines. So
I think there's a Haskell program walking around as well.
okay. I have to admit that my experience is not so Haskell. So, but anyhow, yeah, pipeline. We have two flavors in the meantime. Where Azure DevOps when Azure DevOps started, coming from an on-premise product historically, T-Foundation server, a lot of things in Azure DevOps, and still a lot of things are very visual based, if you want so. We have still a UI that helps you, guides you through the process of creating and changing this continuous pipeline. But, and actually, let me show you that. I was here building a very easy pipeline to be able to create an ASP.NET application, which has also some SQL components into it. The moment the screen loads, actually that's another project. So it's a Java with Spring Boot application that has also some SQL attached to it. And the way this pipeline works is that it has a definition with so-called on the left side here, with those tasks actually telling the pipeline what should you go and do. In this case here, it's actually a Maven-driven pipeline, which is actually building at the end a Java output that is then going potentially to be then hosted on a Tomcat server or wherever you want to. The goal of this pipeline is actually to be, at the end of the day, reusable and automated. So whenever you are going to check in some code, doesn't matter if it comes from GitHub or from the Git repository or from Bitbucket or wherever you're storing your code, that pipeline should actually automatically be kicked on and build all the time with the same setup, the same output, or following the same process to build the output in the same way. And here we're going to build more of a Docker image-based output. Now, is Docker as a technology, is it something that you're also using, or is it a pure ASP.NET sort of?
I'm not using it.
No? Nobody's using it. Good. So the goal of the pipeline here is actually, and I'm missing some whiteboard, usually I'm more of the drawer, so I can do something like that. Let's see. Oh, no, that was the wrong. Let me see. Sketchy. Clean up stuff. I was explaining Azure to a friend of mine yesterday, so it got really weird. Cool. I assume that. I'm not sure what the screen recording is taking that, but let's see. So the idea of having CI and CD, why we're actually splitting that, is the following. Coming from the source code, what the idea of CI is to have automatically something which is listening, so shifting left is listening to whatever happens on your source code repository. And it's like a trigger. So whenever you're checking in something in your source code repository, what should happen is a CD pipeline should be kicked on and is working with so-called tasks to actually go and build whatever sort of software that you would like to build. So what I've shown here is actually, this is a Java application, which at the end gets packed into a Docker container. It's just one way of building an application. That could have been something like, let me actually show you that. Oh, that's just a picture. Here we go. By creating a new pipeline, I can show you all different other templates that we have. That could also be that you're going to be now with .NET Core 3.0, that you're going to be a desktop version of an application, or as somebody mentioned, some Corda or some other like smartphone oriented application. So whatever you're going to build, now let's take this one as an example, you're going to have some sort of building steps that you're going to actually to be able that you need to be able to replicate. And the pipeline here is just a definition of this build, tasks that are needed to achieve at the end to get an output after a compilation. So going back to the, going back to my drawing, the idea or the goal of the pipeline is actually to be able to have at the end some sort of an output, a package, something that you get as an output. And what we have learned at Microsoft, what a lot of customers were doing actually, which we've learned that it was at the end a bad practice, is that a lot of customers sticked with the CI pipeline and just added at the end one very advanced task that said, take that output and go and install it. So that was the install task. The problem with the install task was that there was so much complexity in it. The whole security was there. So who can actually go and install it and who is not allowed to do it? The whole sort of checking things: is the production ready? Is every constraint actually achieved so that I am able to go and install a new application? So everything in one script. What we don't want to have anymore, and why we have introduced now a CD approach, which is then here over this side, is the idea of a CD approach is to have the same build output each and every time, but now to define our CD strategy, saying I want to deploy first to dev, then to a test environment, and then to production. But while I'm actually deploying that software to test first, to test it, or actually to dev, to make some basic tests, and then to the test environment to simulate some users, and then later to production. What I don't want is actually to go and rebuild all the output again. On one side, just because it could take a lot of time. If it's just a web application, I hope that your builds are going to be fast and are done in less than a minute. But imagine in the past where somebody like the Windows XP team started a build. It took them 3 days to build the Windows XP image. Now, if you would have broken something, so there was a high chance that while it was building, you already realized it. Just by, oh, I didn't need to check that. But then the build pipeline was going on, and it took them 3 days to build something. So in this situation, what you don't want to do is actually for testing it on dev or for testing it on test, you don't want to go again through the whole build pipeline. But what you want to do is to recycle the same output, saying, okay, I'm going to take those binaries and install it on a dev environment. If my tests are okay, if I'm doing quality assurance and everything is fine, I'm just going to take the same binaries again and put it into the, in this case, test environment, which potentially could be a simulation of a production. And if everything goes well, I put them on production. From a quality assurance perspective, if something is broken over here, you know that if your tests in the first place here were all green and you're using the same bits and bytes, then it cannot be that the application is broken, but potentially the configuration or other things around it is broken. If you're constantly rebuilding the application, there is the risk, or this is what we've learned, there is the risk that somebody could have checked more code into it or could have changed it while you have deployed first your application into the dev environment. In the meantime, somebody checked in something and you're testing something different when you're deploying it onto the test environment. So this is why we have separated the CI approach from the CD approach. And the experience here, going back to that screen here, and the idea here is actually to be able to generate an output, and that output to be then reused later. And that's like the classic ASP.NET sort of output. Is this the way that you're building software ready today, or if not, what are other options that you're looking at or using? Okay.
I use Cake a lot.
Okay. Use those tasks to generate the output. And when you've generated the output, how do you progress with it?
That's a whole different matter because our our ecosystem doesn't allow yet. As a CMS, we work with modules that are based embedded in the CMS, and although we do have some way to integrate with our store to say to inform users that a new version is available of our module, there's no action path to make it happen from our side that their site
Actively,
right? It's all completely passive. They need to then download it, install it, etc. They know that, but they're warned. I think, you know, what I'm coming from when I look at this is I'm trying to imagine what our world could look like if we could have that kind of a possibility of also delivery through our own mechanisms that we built into the platform.
Now, talking about the delivery of these pieces that actually enhance the DNN platform, whenever such a module is built,
yes.
Now I assume needs to be stored somewhere to be picked up by customers, right? That is sort of a marketplace similar sort of things, right? So what is the usual approach that you're actually taking such an output of, hey, it's there, it's packed, it's available.
It has to be uploaded to the store, yeah.
So you upload it to the store.
In much the same way that you would for Android or iOS.
Okay, and how are you then going to test it? Whether it works on a, let's say, vanilla environment where you're actually then pulling that module and making it available.
You would test it locally yourself because it would install locally. You can run those kind of tests.
Okay.
But as it comes to the larger public, you basically keep your fingers crossed.
I need to ask, the finger crossed feature is not yet there.
That's a very hard one. I just have to warn you, right now the lunch is going to happen right next to us, so it will get very noisy.
Okay.
We have half an hour and then we come back to
okay. There's actually not so much to say actually because the CI/CD is the most important part. So, so that part. So what I wanted to highlight is more the way the architecture, because if we are now switching from the CI part, which is generating an output that now can be reused, and we go to the CD part, the continuous deployment part, the idea of such a continuous deployment part here, actually that's a better example here. The idea of a continuous deployment part, as I was saying, usually is actually to define these sort of environments and to actually give the capability of deploying it, which in this case is somewhere different. Just one feature I want to highlight, because that's what is actually differentiating it from just having a script, is something what we call the approval process, which means that whenever, going back to my image here, which I've already closed again, you see my drawings are all the time challenging to grasp after such a session. So when you have tested your development environment, when you have tested that the module works on premise or on your local environment, what such a pipeline will help you is actually to have a assessment or an approval process saying, okay, before actually you're allowed to publish that into a store, you need to have the approval of a second developer. So that will be that, saying, hey, Peter, please ask a friend of you to download the same module, install it, test it, and only when that second person is giving the approval, the module is going to be uploaded into the store. So this approval process can be somehow, which is different in your case, but that's the whole idea of having such an approval process, which is not actually giving you the ability of splitting the different environments, but of giving the chance for somebody, even outside of the system, to get an email saying, hey, for quality, security, we need to have a second opinion, or even somebody owning the store to say, hey, yes, you are allowed to go and upload the module.
When you were saying testing, are you thinking about running automated testing scripts or manual testing or automated UI testing? Or?
So generally, everything that can be automated being it UI-specific tests, which can be automated, or the more classic code-oriented tests. Everything can be part of either the CI pipeline, so before you check in and produce an output, you want to run some code tests, or performance tests, for example, integration, so outside performance tests, if they can be automated, they can be run here also as part of a task. So you could say, we have an environment where we are simulating an end user, and there we want to run a simulation of 10,000 users accessing that site. So such a simulation, if that can be automated, that can be run here also as a part of our release.
Which testing tools are particularly well integrated to DevOps?
So what we have out of the box, if we go here to the testing part, so we have here Maven tests, we have here App Center tests, which are actually iOS and Android specific tests. We have the whole MS build. And what unfortunately is going to be retired soon are the so-called cloud-based load test based on the cloud, whatever. And the idea was that we would have provided to you like an infrastructure where you could run such simulation. Take 10,000 simulated users over a minute and go and actually use that site. So this is going to be deprecated, but the others are the tests that come out of the box. You can build your own test tasks and then upload it into this if you don't want to use a script, but if you want to have like a configurable task. Behind the scenes, all those are just scripts that get executed. It's just easier to be configured like that. So the test can be run here. And if you want to have some automated tests, some of the manual tests, we have a module called Test Plan, which is exactly for that. It's an organization of tests which needed to be executed in an manual fashion, so that you cannot go and execute them, but you need to have a testing engineer which goes and tests something in a manual fashion. So this is also here available and can be managed like that. I can give them more details in the afternoon. Closing it. So that was the pipeline. Repository, I assume that everybody of you is storing some code in some repository, which is still not 100% the case all over the world, but to have mentioned it. Test plans, I can come back to that in the afternoon. One last question, artifacts. Those modules, are these some sort of artifacts that you are producing and putting it on NuGet or so, or is it more of a... Okay, but still a package.
It's a zip file. The platform knows what to do with zip file.
So it's not like one of those repositories like NuGet or NPM or so that you're using. Okay, interesting. Yeah, that's actually it. So in the afternoon, I'm going then to go deeper into how Microsoft is actually using DevOps to implement DevOps. But in the meantime, if you want to know more about that, we have a lot of videos which are happening. I will, with this slide deck, I will also share all the links that I've shown, where you can get all the documentation information and more information if you want. Buon appetito.